Welcome to the demonstration of the 2D output interface of the new BOSfluids, outlining the available features and options. For this demonstration, we will use the modified hammer model from the standard model folder found in the BOSfluids install directory. In the hammer example, a long pipeline experiences a waterhammer effect by the rapid closure of a valve. An extra scenario has been added to the hammer model where the valve has an increased closure time. This increased closure time shall be confirmed in the 2D output. For this model, the analysis results are already available and we can directly proceed to the Results tab. In the 2D output section of the Results tab, the transient effects can be plotted per node, element, node group, or element group. Firstly, we will be interested in the valve closure times of the two scenarios. The closure of the valve in both scenarios can be shown by plotting them in the same figure like this. Select element from the drop-down list. Select the element name from the drop-down list in the name field. For this example, this is only valve 1. Select both scenarios in the scenario window. Select opening from the Datasets list. Check that the figure is plotted with a time domain and click Plot. The figure shows that in the main model the valve closes in 0.4 seconds and in the scenario 1 shows that the valve closes in 2 seconds. The value of a data point can be seen by selecting on or in the region of the data point. Likewise, the user can zoom into different regions of the graph by clicking and dragging to create a new view window. Double right-click in the window to return to the original plot. The same results can be produced by entering the node numbers of the element in the name field. Or we can zoom into the model and double-click on the valve to display the same results. Note that this only works if the scenario and dataset have already been selected. In the plotted figure, we can customize the plot as we wish by selecting the Settings button. Here, various features are available to modify, including the title, labels, range of the axes, and displaying the key. The plotted data points can be adjusted by entering the Datasets tab. The figure is automatically updated as options are adjusted. The rapid valve closure in both scenarios will result in a pressure wave traveling up and down the system. This can be clearly observed at node 90 and is plotted like this. Select node, enter 90 in the name field. Make sure that both main and scenario 1 are selected and select pressure in the datasets. Here it's clear to see the large pressure spike that is produced due to the valve closure and the oscillating pressure wave through the system after the valve has completely closed in both scenarios. The larger spikes is observed with the faster closing time. A frequency breakdown of the pressure fluctuations in time can be generated for the main model by changing the plot from the time domain to the frequency domain. Unselect scenario 1 and change the domain to frequency domain and select plot. The main contribution of the pressure fluctuation is shown here to have a frequency of 4.16 Hz. This completes a demonstration of the 2D output interface of BOSfluids. You can view demonstrations of other features of BOSfluids on the DRG YouTube channel.